Hello and welcome to the GCSE tutorial for GCSE Physics. This is for topic P4, Atomic Structure, and covers part 1, Models of the Atom, and Atoms, Ions and Isotopes. First of all, the history of the atom. This is something that's also come up in the Chemistry GCSE topic, so it's something that you learn twice. You need to know how the ideas of atomic structure have changed over time. So very early on in the early 19th century, John Dalton said atoms were solid spheres. In 1887, J.J. Thomson came up with the plum pudding model, which is shown at the top here, where he said atoms had negative electrons in it and an atom had an overall positive charge. It was an experiment by Ernest Rutherford in 1909 which developed the theory of the atom further. He fired alpha particles on a thin sheet of gold, which was only one atom thick, or a couple of atoms thick. Some of the particles were reflected back, which was surprising because he thought they'd all pass through. Now, because alpha particles are positive, he concluded that the reason they were reflected back is they were being repelled by something else positive in the centre of the atom, and that's where the idea of the nucleus came up. Niels Bohr then added that electrons are arranged in shells or levels around the nucleus, and then later on in time scientists discovered the protons and then the neutrons. So the modern day atomic structure is shown at the bottom. So remember, the nucleus makes up most of the mass of an atom, and that contains protons which are positive and neutrons that are neutral. So because the neutrons have no charge, the nucleus is positive overall because of the protons. The electrons are found in the shells, and most of the atom is empty space. Overall, an atom has no charge, and that's because the protons that are positive is the same number as electrons which are negative. Now remember, electrons can move and leave a shell or can leave an atom. If electrons gain energy by absorbing electromagnetic radiation, they move away from the nucleus. If electrons release energy, they move closer to the nucleus. So what are isotopes? Well, isotopes are a really important part of the radiation topic. They are basically different versions of an element. They've got the same atomic number, but they have a different mass number, and that's because they have a different number of neutrons in the nucleus. If you look at the table there, there's 3 isotopes of hydrogen. The top one is hydrogen that you'd find in the periodic table. But the other 2, hydrogen 2, that has 1 neutron. Hydrogen 3 has 2 neutrons. So they are isotopes of hydrogen. They have got a different mass number. Hydrogen 2 has a mass number of 2, hydrogen 3 has a mass number of 3. So if you look in the nucleus, they've got a different number of neutrons. So these are all isotopes. Now, isotopes are often unstable and they want to become stable. So in order to do this, they give out radiation and decay and break down. Now, ionizing radiation is radiation that ionizes atoms. And what that means is it knocks off the electrons in the shells to turn the atoms into ions. There's 3 types of ionizing radiation that you'll need to know about: alpha, beta and gamma. In the next tutorials, we'll talk about those types of radiation in more detail. If you pause the tutorial now and try and answer these 2 questions. Okay, so how did Rutherford determine that atoms had a positive nucleus? Look at the diagram here. He fired a beam of alpha particles, which are positive, at a sheet of thin gold foil. He thought that all the particles would go through. Now, most did, but if you look at the diagram, some were reflected back. And he realised there must be something in the atoms that's positive as well that was repelling the alpha particles back. And this is how he concluded there was a positive nucleus in the atom. He also concluded that because most of the alpha particles went straight through, most of an atom is actually empty space. Why is the mass number of chlorine 35.5? If you look in the periodic table, it's got this number 35.5. Why? Well, that's because there's actually 2 isotopes of chlorine. There's chlorine 35 and chlorine 37. But the mass is not an average of both, which is 36, because there is more chlorine 35. It's more abundant. So the mass is calculated based on the fact that 75% of chlorine is actually chlorine-35. So the overall mass number of chlorine is based on the two isotopes and is 35.5. In summary, we've looked at models of the atom and atoms, ions and isotopes.